Repetition in programs is something that programmers can do to save space and save time and effort, because a computer can repeat an instruction perfectly as many times as you want without getting bored like a human might, or making an error like a human might, as long as you code it correctly. Now, to give an example here, I've written a really simple stack of code. When I click the green flag, Gobo is going to move 10 steps and change size by 10, so you'll get a bit bigger. So I click the green flag, 10 steps across the page, and he's got a bit bigger. And I can keep going like that. Each time I click it, he's moving and he's getting a bit bigger. Now, if I wanted to make him do that 10 times, I could click the green flag 10 times, but programs are against things like that. They want to make things more efficient and easier. So I could duplicate my code. So I could have it where I write out over and over again all the lines of code I want to happen. So 10 times, move, change size, move, change size. Lots of duplication. My code would go down the page, and in the early days of computing, that would take up a lot of memory. So repeat loops were invented. Now we can access these by going into control and accessing a repeat loop. All this means is effectively the instruction of the block is initially ignored, and I put my code that I want to happen inside the jaws, note so it spreads to fit. And when I read down my stack now, when I hit the green flag, it's a repeat loop, so I jump down a line. He's going to move 10 steps and change size by 10. Then I'm going to go back up to the top of it, and I'm going to do this again, and I'm going to work through my loop 10 times. So he's going to make 10 movements of 10 steps and 10 size changes. So he'll move 10 steps, change size by 10. Here we go when I hit the green flag. There we go. So he's done that operation, move 10 steps and change size by 10 times. Whatever's in the loop happens in the order, because it's according to sequence that it's in. So it's moved from the top to the bottom. The little arrow is the key. We just jump back up to the top of the loop. We must complete the loop before we can go on to the next block. So if I'd put down at the bottom that he's going to play pop, let's just try this again. What will happen is he won't play pop each time. He'll play pop at the end of his sequence. So he'll move 10 times and change size 10 times. That'll be repeated, and then he'll pop. Whereas if I put pop inside the loop, he's now going to pop 10 times. So putting it inside the loop, there you go, I get 10 pops. So that's an important feature of loops, that everything inside the loop must be executed before we move on to the next block outside, and whatever's inside the loop happens in the sequence it is in. The number of times that is repeated is variable. You can click whatever you want in there. You could have it repeat 100 times, so you could disappear off the screen into a gigantic gobo. Let's just try that one. So we've lost him there. Or you could have it repeat just the once. You can also, as you see later, use variables in there to adjust how many times that happens. The other option there is as well, I'm going to just slightly reduce how much bigger he gets each time, because this one's going to go quick bigly, is I can use a control loop that is called a forever loop. Now you notice this doesn't have any connection on the bottom. A forever loop continues on an infinite number of times. So when I click this one, he would continue getting bigger and bigger and bigger and bigger forever. Need to be very careful with forever loops, because there is no ending to it. I can't stop the loop. There's no condition for it. It will just carry on and on and on and on and on. So as soon as I click that, you can see I've got Gobo off the edge here. I'll bring him back if I can. And he's just going to keep on growing and growing and growing and popping away. So that is something to be careful with, but it is an option. And those are repetitions, or repetition loops. Final feature that's worth remembering is that, like all blocks in Scratch, you can combine them. You can put repeat loops inside repeat loops. This is where you start building more and more code. A lot of the code you will see, especially start with green flag, will begin with a forever loop around the outside, because that means that once you click the green flag, everything inside that forever loop is repeated or can be done. So that is repetition.